As you know, our solar system is truly enormous, and it would take us an immeasurable amount of time to make the journey with a simple rocket engine. But there is an old design that was invented half a century ago. With this technology, the duration of the flight can be significantly reduced. This is a nuclear engine. Let's see what a flight to Mars would look like with a simple chemical engine. We leave Earth and make our way to low Earth orbit. Then we turn on the engine for departure, and we set off in the direction opposite to the Sun. The unusual new elliptical path we travel to Mars over the course of 8 months is called a Hohmann transfer. It's one of the most effective methods of space travel, using the minimum amount of fuel and carrying the maximum useful payload. Astronauts need food, water, and air. During a long flight, they are affected by cosmic radiation. Add to that the return journey as well. In the early 1960s, NASA and the Atomic Energy Commission came up with a system for calculating nuclear thermal power, or NTP. Scientists conducted a number of successful tests of nuclear thermal engines, thereby verifying their functionality. Newton's third law says every action has an equal and opposite reaction. As a result, the rocket gains velocity in the direction opposite the gas exhaust. A nuclear engine operates according to similar principles. Hydrogen is supplied from the tank into the reactor core, where, passing through channels heated by nuclear fission reactions, it is heated to high temperatures and then expelled through nozzles, creating thrust. The thrust is so great that the efficiency is 2.3 times higher than that of a chemical rocket engine. A journey with such an engine would take 8 months, but a nuclear thermal rocket engine would cut this time in half, making it possible to reach Mars in just 3 months. And this means that astronauts will need fewer resources, and they will be exposed to less radiation. And another advantage, with a nuclear rocket engine, it's possible to travel from Earth to Mars without waiting for the closest approach between the red and blue planets. With a chemical engine, if you miss the required window, you'll have to wait a whole 24 months. But with a nuclear rocket engine, you don't have to cancel the flight. The first tests of the nuclear engine began in 1955 as part of Project Rover at the Los Alamos Laboratory, with the key task being to reduce the size of the reactor enough to make it manageable so that it could be integrated into a rocket engine. NASA organized the landing of astronauts on the Moon under the Apollo program and is planning a mission to Mars. Because of the great distance and travel time, it was decided that nuclear engines would make these flights the most realistic. Naturally, nuclear engines have their own dangers. A reactor on the ship is a source of dangerous radiation, which can have a negative impact on the crew. But by reducing the flight time, the radiation dose will become lower. Open outer space is a source of powerful radiation that can destroy astronauts' DNA. The project also included nuclear rocket technologies for sending humans to Mars. Powerful nuclear engines were tested in the Nevada deserts, which expelled gas at high speed. The first transformation of NERVA was tested for a period of 2 minutes. Out of 2 hours, 28 minutes were at full load. The engine was tested 28 times over a period of 115 minutes. Eventually, tests were conducted on the nuclear reactor Phoebus 2A, which is capable of producing 4,000 megawatts during a 14-minute run. Everything was ready for the flight to Mars, but the United States changed its mind about going there. Instead, they decided to build a space shuttle. Since 1973, no one has tested nuclear engines. Over the years, technology has improved, and now creating something similar looks even more realistic. Because in the 60s, the fuel that was used was enriched uranium. Now, engineers believe that regular fuel for nuclear power plants will do. It is not dangerous, and the list of test sites where checks can be carried out is much broader. In addition, it will be much easier to isolate radioactive particles in the exhaust and get rid of them. Thanks to this, the overall cost of the project can be reduced. On May 22, 2019, the United States Congress allocated $125 million for the development of nuclear thermal rocket engines. But this is in no way connected to Artemis 2024 and NASA's project to restore the planet.
На Луну. Просто процитируем.
The project is to create a long-term plan. This year, the project was launched in Kazakhstan. Artemis 2024 will be part of this in Kazakhstan, in Artemis and Artemis, with space trials and a planned schedule of future missions. So what about thermonuclear engines?
Распад ядра – это метод применения атома, для которого необходим обогащенный уран. Впоследствии этого появляется ядовитый радиационный.
Trash. What about thermonuclear fusion? A thermonuclear reaction happens on the Sun because of the high temperature of its core. Implementing thermonuclear effects for the service of humanity still remains a difficult task for mankind. In the case of the impractical use of rocket nuclear reactors, especially as an inexhaustible energy source, they have enormous thrust. And it is quite likely that we won't have to wait for years for this. Researchers from the Princeton Plasma Physics Laboratory are studying the theory of direct fusion drive, or DFD. Their research is based on a fusion reactor created by Samuel Cohen in 2002, which uses the principle of a field-reversed configuration. The reaction between helium-3 and deuterium plasma takes place in a magnetic confinement container. As a result, we use much less energy, and we also have an order of magnitude less radioactive waste. In nuclear rocket and thermonuclear engines, the fuel is heated to a high degree and expelled, creating thrust. This is roughly how it works. A number of linear magnets are arranged in a row to slow the plasma's heating. Special antennas around the substance are tuned to a specific ion frequency, which creates a current in the plasma. The activity of the ions enhances the properties of the atoms, which when combined form new particles. These particles move in the magnetic field until they are joined by other particles and expelled through the rocket engine nozzles. At the theoretical level, a nuclear rocket engine can provide thrust from 2.5 to 5 newtons per megawatt of power and specific impulse, up to 10,000 seconds. For comparison, nuclear engines have this parameter at 850 seconds, while chemical engines have it at 450 seconds. DFD can also generate electricity for the spacecraft far from the Sun when solar panels are not in use. DFD has the capability to move an object with a mass of 10,000 tons to Saturn in 2 years, or something with a mass of 1,000 tons to Pluto in 4 years. It took New Horizons 10 years to do that. The DFD, among other things, is a 1 megawatt nuclear fusion reactor, and during a journey through space, it has the ability to power all the equipment on board. That's much more than what is provided by the nuclear batteries installed on spacecraft from missions like Voyager and New Horizons. Of course, it's been more than 10 years since NASA last conducted tests of nuclear propulsion engines. But we believe that in the coming years, we will see completely new developments and new tests of systems built using these technologies. I'm incredibly inspired by the fact that with the help of these technologies, we're increasing our chances of visiting other planets. What kind of budget do you think is needed to become the first space tourist on Mars? Dollars. According to Elon Musk, that's the amount you need to easily leave the bounds of our vast planet. But did you know that you have the opportunity to see the beauty of Mars and hear what it sounds like without leaving Earth? In recent years, humanity has made great strides forward. At the time this video was made, it had been just over a month since Perseverance landed on the surface of the red planet, and specialists from NASA continue to receive information from it. On March 17, NASA released an audio recording made on March 7 using a microphone installed on the rover, and it lasts a full 16 minutes. We have already heard the sound of the Martian wind, and now we can analyze the noise made by the rover itself as it moves across Mars, where it traveled just over 27 meters. And this is really very interesting because in addition to the creaking of the rover's tracks, the recording also captured some rather curious knocks and tapping sounds. On the SoundCloud website, there are two versions of the recording, the full one and a 90-second cut in which extraneous noises have been filtered out. Listen for yourself. What do these sounds make you think of? Here we hear the Mars rover starting to move, followed by metallic tapping sounds. The tapping is also audible elsewhere in the recording. And in some places, you can hear a real rumble. Doesn't it sound like Martians attacked Perseverance and are trying to break into it? But everything is explained much more simply. Many people, when they see a picture of the rover, don't realize that the wheels are made of metal. When you drive on these wheels over rocks, it's actually very noisy, said Vandy Verma, a senior NASA engineer in Southern California and a driver of Perseverance. Why are the recordings from Perseverance so important to us? Perseverance is the first rover that managed to successfully record and transmit audio from Mars, since previous attempts had failed. Microphones were installed on the Mars Polar Lander rover, which crashed during its landing on the surface of Mars, and also on the Phoenix lander, which, despite a successful landing, was unable to make recordings due to electronics problems. But that's not all. The rover's cameras also captured a real Martian dust vortex, also known as a dust devil. We don't know its speed or height, but it's known that dust devils on Mars can reach up to 8 kilometers in height. The mechanics of their formation are the same as on Earth, and they consist of the interaction between the sun-heated surface and the cold and hot air currents above it. From space, such whirlwinds look like this. Impressive, isn't it? What do you think? Could such natural phenomena on Mars hinder future colonization? Share your opinion in the comments. But let's get back to Perseverance. Perseverance is already making real breakthroughs, far surpassing its predecessors. And who knows what we will see and hear when the cameras on the Ingenuity drone, which is still charging, are switched on and it soon begins its flight over Mars. What is your opinion on nuclear weapons? Are you sure that 99.9% of respondents will respond very negatively, saying it brings death? Then perhaps, would you prefer a comet or asteroid strike? Most of us wouldn't be enthusiastic about that prospect either. But in the universe, things aren't so simple. If a meteorite attack threatens Earthlings with destruction, there are planets for which these catastrophic events, on the contrary, mean the birth of life. For example, our dusty neighbor Mars is one of them. I wonder what would happen if the red planet was bombarded with hydrogen bombs. No, we haven't gone crazy. This extravagant idea comes from Elon Musk and other progressive minds who are actively looking for a new home for humanity. You can understand the American engineer, since colonizing Mars is the main goal of the famous inventor. But warheads are just too much. And yet, it is in this way that Elon hopes to bring the red planet to life. The idea is simple. The plan is to detonate several hydrogen bombs over the polar ice caps of Mars. This will heat up the ice there, releasing carbon dioxide and water vapor. Then, the greenhouse effect will gradually make the temperature on the planet much more comfortable than the current minus 63 degrees Celsius. And over time, Mars will become a second Earth. That's the plan in general terms, but is it actually possible to implement it? Elon believes that Mars is full of carbon dioxide, not only at the poles. Therefore, when heated, it will be released everywhere from the soil of the disturbed planet. But scientists strongly disagree with this. That's why we don't see bright explosive flashes yet, and aren't admiring the alluring greenish-blue Martian surface through telescopes. The topic of colonizing Mars has been relevant for years, but only recently have astrobiologists and physicists begun to discuss scenarios for terraforming the planet. Before that, no one really envied the fate of future colonists. What awaits them on the cold celestial body? If they're lucky and the astronauts don't die from harsh cosmic radiation and the G-forces during landing, and also don't go insane on the way, then they're destined for a bleak existence in complete isolation among barren lands. Grueling work at autonomous bases growing food, the amount of which will be strictly limited, and living in glass hangars in caves illuminated by artificial light sources. And if a colonist decides to get acquainted with the authentic Martian world, they'll have to put on a bulky spacesuit and leave the shelter at their own risk. it's clear that terraforming the red planet would significantly simplify life for newcomers from Earth. So why haven't we taken up Musk's idea and started bombing Mars yet? The thing is, the effect might turn out to be far from what we expect. Mars has been losing its atmosphere for millions of years, so the first thing we need to do is restore it to Earth-like conditions. At the same time, it has been proven that the release of CO2 and water molecules caused by remote nuclear explosions would give the Martian atmosphere only 7% of the layer that surrounds Earth. The pressure in such an atmosphere would rise to only 7.1 kPa, while plants need at least 50 kPa to develop. But what if the orthodox astronomers are wrong and Elon is right, claiming that the Martian soil hides huge reserves of carbon dioxide stored not only at the poles? Even if that's the case, the process of warming up the planet would take a huge amount of time, which would significantly delay its colonization. Besides, we're forgetting the main thing. Nuclear weapons are extremely dangerous and can destroy everything in their path. What if some of the bombs actually reach the surface of the red planet? Naturally, they would cause serious damage to it and cover it with a dense blanket of radiation. Mars would instantly turn into a kind of Chernobyl, becoming not only lifeless, but also a poisoned desert. That's why scientists at NASA and other space research agencies don't share Elon Musk's fanatical enthusiasm. Moreover, based on data from the Mars Reconnaissance Orbiter and Mars Odyssey orbital probes, they believe that the red planet cannot be terraformed, meaning it's almost impossible to make it suitable for life. The verdict is disappointing, but it's not final, right? But then why did the Mars One colonization program cease to exist in 2019? Anyway, there are still a few ways to bombard Mars so that after centuries, it could become a haven for Earthlings. Bombardment with asteroids. This means a controlled attack on the red planet with a swarm of meteorites and large comets, or crashing one of Jupiter's moons onto Mars. The effect will be similar to nuclear explosions, only without radioactive contamination. But there's also a flaw in the proposed scheme. This includes inevitable destruction and unknown consequences from the impacts, up to changes in the object's rotation and orbit parameters. That's why this method of terraforming requires thorough refinement. An explosion from within. To initiate the self-generation of a magnetic field on the red planet Mars, it will be necessary to place bombs inside it. They plan to place them near the core, and when the charges detonate, it will likely trigger the magnetohydrodynamic dynamo mechanism. But for this scenario to work, one condition is necessary: a liquid outer core. Atmospheric glass. The exotic name hides a strange attempt to turn Mars into a pale imitation of Earth. Some particularly optimistic scientists suggest deepening the already gigantic crack from 11 to 60 kilometers and placing a thermonuclear charge there. Gravity will gather Martian atmospheric remnants in the depression, creating the pressure needed for breathing. This is the most unusual of all the methods involving explosions. In addition to bombardment, other methods of terraforming Mars have also been devised. For example, to create the conditions for a magnetic field, it's not necessary to blow up the Martian core. It's enough to lay a continuous superconducting cable along the equator and connect it to a powerful energy source. Or install a magnetic shield at the Lagrange point, protecting the red planet from the sun and helping its atmosphere naturally recover, which is being carried away by the solar wind. But the most ingenious method of making it habitable is to build a series of industrial plants on its surface, causing a greenhouse effect and triggering a chain of terraforming events. But is at least part of these ambitious plans even feasible? For now, these are just thought experiments, too costly and energy intensive to become reality. Although perhaps the scientists are wrong, and Mars will eventually bloom just as beautifully as Earth. Right now, the colonists are taking a risk, saying goodbye to their home planet forever and getting a one-way ticket. Humanity considers Mars to be the most suitable planet for colonization, but people will have to live in special modules or under the Martian soil. The most favorable outcome would be a planet already suitable for living, with a comfortable temperature and atmosphere. Despite the fact that Mars is in the habitable zone, it is cold, radioactive, and unsuitable for human life. The atmosphere on Mars is escaping due to low gravity. Its greenhouse effect is so insignificant that it does not have a significant impact on the average temperature on the planet. But does humanity have any means by which this can somehow be changed? The most feasible option is detonating several megaton nuclear bombs on Mars. Thousands of tons of dust lifted into the air will create dense clouds that will reflect a huge amount of solar heat back onto the planet. You might say that this will make the surface of the planet radioactive. But Mars already has a high level of ionizing radiation coming from the sun, doesn't it? However, the most important issue will be solved: the temperature at the surface. The cost of devices and modules that won't need protection from the cold will drop significantly. Dust clouds, however, will block a significant number of solar photons in the gamma ray range. The difference between residual radiation from explosions and radiation from the sun is that energy from the sun comes continuously, unlike explosions. The level of radiation will decrease exponentially. For example, if the level of ionizing radiation is considered 100% 1 hour after the explosion, then after 7 hours it will be at 10%, and after 70 hours at 1%, and after 700 hours 0.1%. But what is there to study? It's better to see for yourself, right?
This is Mars in the Space Simulator Universe Sandbox 2. Since the game currently doesn't have the ability to create nuclear explosions on the surface, I just spawned a couple of asteroids near the surface and programmed them to explode. For the sake of simulation accuracy, I placed Mars at a realistic distance from the sun so it wouldn't lose its temperature, and I locked both objects in place. For the experiment's accuracy, we will measure the power of the nuclear explosion on a scale where 1 unit equals the power of the Hiroshima atomic bomb. The most powerful existing bomb in the world right now is the Tsar Bomba. It has an equivalent of about 10,000 Hiroshimas. We will conduct the experiment with different explosive yields. The first experiment involves detonating 5 objects on the red planet's surface, each with 100,000 times Hiroshima's power, 10 times stronger than Earth's most powerful bomb. The second experiment will use 200,000 each, the third 500,000, and then a blast equal to 10 million Hiroshima bombs. That will be awesome! All the explosions will take place at the planet's equator. Subtitles. As you can see, this practically had no effect. It's worth mentioning that the planets in the simulator have an albedo, which depends on many parameters, including the color of the surface, the color and density of the atmosphere, the material of the absorbing surface, and so on. Even I can't list all the parameters that this value affects in this program. For those who don't know, albedo is a characteristic of a diffuse reflecting surface that depends on the wavelength. Yeah, light is both a wave and a stream of particles. Yes, light is... If you put on swimming goggles and someone asks you why you need them, you can confidently answer, well, light is a wave. This is called wave-particle duality. So, there is albedo, but unfortunately, since the planet's characteristics don't include a parameter like dust lifted from the surface, our simulator, of course, won't be able to take it into account. But it will be able to account for different levels of energy absorption in matter that Mars's gravity can retain. As we saw, on the planet, we reached a maximum peak temperature of 1200 degrees Celsius. Well, that's all I managed to see. At the moment of the explosion, the epicenter's temperature is much higher, but that brief period is so short we didn't consider it. But a video isn't as fun without some spectacle, right? By detonating a nuclear charge several orders of magnitude more powerful than anything on Earth. The simulator's explosion tool includes an option to auto-calculate the explosion's power. As far as I understand, it simply takes the mass and calculates the explosion's energy using the well-known formula. E equals mc2, that is, energy equals the speed of light squared multiplied by the mass. Let's take something really big to get some impressive results. Well, some kind of cosmic object, for example, the size of Europa. Oh, that was awesome. But what conclusions can we draw in the end? No explosions, no artificial or rapid heating will allow us to achieve a normal temperature on Mars naturally. The cheapest and most feasible way for humanity right now is to dig deep underground mines closer to the planet's core. Because it's warmer there, there's no radiation, and you can create a closed ecosystem there. The small mass, non-rotating core, and lack of a magnetic field put an end to any of my attempts to make Mars suitable for life. But this is just a simulation. What will happen in reality, we can only find out by testing it in reality. In general, humanity has long been capable of projects on such a scale as installing a planetary focusing lens at the Lagrange point, terraforming Mars, manned missions there, and so on. But since humanity is still divided, fussing around in its own countries, concerned only with lining their own pockets, defending national interests, and other petty everyday matters, it simply cannot live in harmony and reach these heights. We should take a lesson from nature. All the cells and organs in our body live in harmony and work for the benefit of a single individual. If we ever manage to create a planetary organism out of people, it will be the greatest step in human history. Due to the absence of those who are different beyond our planet, people look for those who are different among their own civilization, nation, people, race, and so on. For a new space race and the conquest of space, we simply need an alien invasion. But perhaps this is something to discuss in another video. I really hope you enjoyed this format. This is a bit different from the experiment we did with Alexander Kubel before, and it should be more familiar to you. There were also some surprise comments under that video about how Kubel's voice had changed in a strange way, which in turn really surprised us. After all, it's obvious that a different voice belongs to a different person. That's all. Thank you for watching. Don't forget to like and subscribe to the channel.